Hi everyone, in this video we are going to attempt old Regents questions that are related to isotopes, isotope notation, identifying atom attributes when given isotope notation, and how to use mass number and relative abundance to calculate the weighted average of a sample of a naturally occurring isotope. So let's begin. All right. Number one, which isotope contains the greatest number of neutrons? So let's examine each of these individually. Chlorine has a mass of 37, and well, let's examine what its number of protons is by looking at the periodic table. And there is chlorine right here, and it has an atomic number of 17, and that says that it has 17 protons. So a mass of 17 straight from the protons. So we will put 17 here. And if you recall, the mass is protons plus neutrons. So to get the number of neutrons of chlorine, we subtract 37 or 17 from 37, and it has 20 neutrons. Let's put 20 right there. All right. Now for argon. Argon with a mass of 40. Let's find argon. There she is on the far right. Argon has an atomic number of 18. So using the same logic, we put an 18 here. So what is the difference between 40 and 18? And that is 22. So that's 22 neutrons. All right, so now potassium, 39. Potassium 39. Okay, potassium has 19 protons. So let's put that in. 19. So mass of 39, 19 of that mass comes from protons. 20 of it must come from neutrons. We have 20 neutrons. And lastly, calcium. Calcium has a mass of 41. There is the table right here. It has an atomic number of 20. Once again, means that there are 20 protons. The mass from protons is 20. And subtract 41 from 20, you get 21. So which of these has the most neutrons? It would be choice C, argon. All right, number two, an isotope of which element has an atomic number of 6 and a mass number of 14? So it has an atomic number of 6. If the atomic number is 6, it says it has 6 protons, but that is really of little consequence here because we only have to go to the periodic table and look for the element that has an atomic number of 6. And that's right here. It happens to be carbon. Is that a choice? I certainly hope so. It is. The answer is A. Number 3. Which symbol represents an isotope of carbon? So we are looking for an element that has the same atomic number as carbon. So let's investigate our periodic table and see what atomic number are we looking for carbon. And as it turns out, carbon has an atomic number of 6. It has 6 protons. So which one of these has an atomic number of 6? And there it is. So the answer is C. Alright, question 4 relates to this chart here. In fact, questions 4 through 6 are using the same chart. And the question says, in terms of atomic particles, state one difference between the 3 isotopes of neon. Now, I love these questions because the Regents love them, and I have to go over them with you. And the key here says, in terms of atomic particles. So you have to talk about atomic particles. Now, what particles do we know of? Well, we know about electrons. We know about protons. And we also know about neutrons. Forgive the spelling there. It's neutrons at the end. Alright, so if all of these are neon, they have the same number of protons. So we're not talking about protons. And in no way, shape, or form is this chart talking about electrons because it's not talking about charge in any sense of the word. So here we have neon 20, neon 21, and neon 22. What would allow for these mass numbers to be different? Well, it has to be difference in the number of neutrons. So let's go back to the question. I'll undo this, clean up my screen a little bit. And we're going to be talking about neon. In terms of atomic particles, state one difference between the three isotopes of neon. And we must say that a difference between all three isotopes of neon is the number of neutrons. Alright, number 5 uses the same chart and it asks, well, it tells you, based on the atomic masses and the natural abundances shown in the data table, show a correct numerical setup for calculating the average atomic mass for neon. Now, you do not actually have to solve this because it just wants to see the setup, but I'm actually going to go full board and solve it. Now, the way to first look at this is we have a natural abundance of neon 20, and it's 90.9%, where the balance goes neon 21, 0.3%, and neon 22 is 8.8%. If you actually total all that together, that's 100% of what's there. But we do know that a percentage could be based out of 1 instead of out of 100. And for that, we end up doing a decimal equivalent of the percentage and make it out of 1 instead of 100. So we divide each of these numbers by 100, so it will be out of 1. And let's see what that kind of looks like. So instead of 90.9, it would be 0.909. Instead of 0.3%, it would be 0.003. And instead of 8.8%, it would be 0.088. Now to confirm, if you actually add all of these together, you will get 1, just to confirm that you did do that correctly, convert the percentage to the decimal equivalent. So let me take that off there and show you what to do next. The thing to do next is the following. You must multiply the decimal equivalent by the mass shown here. So 0.909 times 20, the 0.003 times 21, and the 0.088 is times 22. And what that gives you each time is the following. We end up with 1.88. Let me make that a little smaller so it fits. Good. We end up with, I'll do the same thing. Good. And there's the last. Now to finish this off, what we would do is add these together. And what you get then is 20.003. Now that is the weighted average of the naturally occurring isotopes of neon based on their percentages. So it's 20.003. That would be AMUs. And this is then termed, instead of mass number, this is called the atomic mass. There you go. Number 6 is using the same information based on natural abundances. The average atomic mass of neon is closest to which number? Well, there are two ways to do this. you could consider what we just went through, and we had our final answer to be 20.003 AMU, which would definitely suggest that the closest whole number would be 20. But you could also just inspect the data. If 90.9% of that mass comes from neon 20, chances are it's going to significantly impact the final results. It's weighted heavily towards the neon 20. So that too brings you towards your answer. The closest whole number is 20. And again, let's throw in the units, even though it doesn't really ask you for it. It's just asking you for the whole number. It's always best to have the units present. It's a good habit. And last, number 7. What information is necessary to determine the atomic mass of the element of chlorine? A says the atomic mass of each artificially produced isotope of chlorine. Artificially? I don't even know what they're talking about here. And actually, let's skip ahead to D because it also says artificially. So let's get rid of that. So we're looking at B and C. What is the difference? B is saying the relative abundance of each naturally occurring isotope of chlorine only. So this says just the percentages. So roll back to question 6 where it was 90.9% of one of them and 8.8% of the other and 0.3 of the other. Was that enough? Absolutely not. Because what we also need is not only the relative abundance, which is the percentages, but we need to know the mass that is associated with each of those percentages. So the best answer is C.